Good. Okay, we're good to go. All right, everybody, welcome to the Wednesday morning plenary. Today we're going to hear from all of the science collaborations, but first I'm just going to give you your reminders that we have a code of conduct. You can find it in the PCW website or by using this QR code. Reminder to check people's name tags for their comfort levels with contact, and to wear a mask if you want to or if you feel sick, and to keep an eye out for those social battery pins. And if you feel unsafe at any time, do use this email address. It goes straight to Ren Powell and I think maybe one other person. Our virtual participants should please stay muted throughout today. I think this is a very packed plenary, so you're going to hear a lot of talks. We're not going to really be doing questions from the audience, but SLAC is the place to go to ask your questions. So we'll make sure that the appropriate speaker is notified of your question. So use Slack for questions and not Zoom. And that's it for today's reminders. I'm going to hand it right over to Will. Yay.
Thanks very much, Melissa. Thank you all for coming this morning. Good to see people. Yes, as you've heard, this will be a fairly busy session because there's so much great stuff the science collaborations are doing that we're excited to tell you about. So I'll give a quick overview, and you'll hear presentations from various representatives of the science collaborations before we move into the lightning talks for the last 20 or so minutes of the session. To help you organise your listening, like I say, I'll give a quick overview, a few examples of what we are and what we do, and then you'll hear some highlights from the 8 science collaborations. Depending on time, we've identified a few issues and challenges that we had thought about before PCW that we'll present if there's time to do so. And I'll finish up by just helping you have an idea of how to get involved and how to contribute to these science collaborations. Just to sort of refresh what Melissa just pointed out, this is a very busy session. We may not have time to answer questions, so please, if you could direct your questions to the Slack channel here, day 3, Wednesday, 9:00 plenary Sci Collabs. If you can indicate which science collaboration you're asking the question to, that would be helpful. And we will do our best to answer questions, if not in real time, at least after the session and throughout the meeting. Okay, so who are we and what do we do? The Rubin Observatory LSST science collaborations represent a federation of independent, worldwide scientists, communities, self-organized based on our interests to both do Rubin science and help the Rubin project help the science be possible. A good idea of who we are and what we do is given by some of the examples you can see here. We work to prepare for LSST, main survey. We provide expert advice analysis to Rubin. We work to train and educate each other and the scientific community in what would be possible with Rubin. We work to fundraise for our teams and their projects. We work to develop and implement research inclusion practices and work on software development. That covers most, I think, of what the science collaborations do. So what are those interests? I think, as everyone in the room already knows, LSST will furnish data to do a huge range of science above planet Earth, all the way out from the very reaches of the distant universe right down to asteroids at distance 0, or hopefully not quite 0. We can help with that. And so you'll hear in a few minutes from the 8 science collaborations arranged around these ideas from sort of close distance to far distance. You'll see these logos all throughout the talk, but we have solar system, you'll hear from dark energy, you'll hear from informatics and statistics, there's a transit and variable stars group, there's a galaxies collaboration, stars, Milky Way, and local volume. It's a bit of a mouthful. That's basically from nearby stars out to the local volume. The strong lensing science collaboration will present, and you'll hear from active galactic nuclei. And between them, these cover pretty much the entire range of science that Rubin will do. If you're interested to learn the sort of responsibilities and rights of the collaborations, the link to this Federation Charter is there on the website there. But the main point I want to make with this slide is that we're trying to be as inclusive as possible. We have members all over the world. We're now up to about 2,300 unique individuals, many of whom are in multiple science collaborations depending on their interests. with a huge range of affiliations in many countries. There are no membership fees for any science collaboration. Anybody is welcome to join. There's no requirement to be affiliated with any organization. You can join us in individual. You don't have to be part of a Research One institution to join. And this may not be quite as well known. There's no requirement on time commitment for basic membership of any of the science collaborations. If you've been thinking of joining a science collaboration but have not been sure whether your teaching schedule allows you to contribute sufficient time to meet your own research standards to contribute, please get in touch anyway. Particularly as we're ramping, as the project ramps up to first photon and then commissioning and operations. I think I can speak without fear of contradiction that all the science collaborations are to some extent person power limited. So really, the more the better. Collaboration is welcome. New members are welcomed. And as I say, if you have an interest, please get in touch. There's also no constraint from the Rubin project on being a data rights holder to join a science collaboration. About half the science collaborations, for good reasons, actually have chosen themselves to require data rights status to join, but not all of them do. So again, if you're interested, please get in touch with the science collaboration that interests you, and we'd be delighted to discuss. So we are a global group of individuals, all of whom have an interest in one way or another in contributing to Rubin Science. And if you're interested at all, please do get in touch. One of the advantages of having the science collaborations is that we're plugged in into many sort of levels of the Rubin ecosystem. There's communication channels, both between the science collaborations and I think importantly between the science collaborations and the construction project, and operations. And this comprehensive diagram prepared by Fed Bianco a few years ago illustrates many of these connections. For example, the all-important observing strategy. Every science collaboration has a liaison with the SCOC that's doing that. We have semi-regular meetings between the science collaborations and the project science team, which is very helpful for the communication sort of both directions between the collaborations and the science team. And then there's lots of roles you can see here on the screen. Those of you who are interested, you can ask me, or you can look at this diagram in more detail later on. But the sort of punchline here is that the project listens to us and we listen to the project. So we really try and sort of influence in both directions the flow of information and decisions. Okay, so this is what we do. You'll hear a lot about these individual ideas from the science collaboration. So I'll stop talking in a couple of minutes and let them speak. But just to flash up a couple of examples of some of these activities. You'll hear a lot this week about the observing strategy. The science collaborations have been very active in working with the project to try to determine sort of what observing strategies would be good for science case X or bad for science case X. And so the science collaborations have been very busy in various rounds of providing that information. One recent highlight I do want to just point out is this special edition in the Astrophysical Journal supplement series led by my predecessor, Federico Bianco, for which these determinations of the science one can do with Rubin and how to configure the Rubin strategy to do this have been sort of evolved into published papers. And so far, I believe there are 18 published and 11 more in preparation or under review. So in a very real sense, this provides some sort of currency to those who've put their time into helping determine the strategy for the observatory this way. An example of training, education, and engagement. One of the science collaborations, TVS led this funded program to actually stand up courses in software training. And you may hear a bit more about that today, but if you're interested, if you go to the Preparing for Astrophysics with LSST program website, you can find this. So we do try and sort of train each other by the experts, not just what we think a good idea may or may not be. In terms of fundraising, we've benefited very much from relationships with the various Rubin organizations, particularly the Rubin LSST, Discovery Alliance. We've done very well in terms of being able to sort of help to influence these funding programs at the $10 to the $4 level, roughly, and to benefit from them. And so you'll hear a little bit later on about some of the things we've done with these enabling science calls, for example. And just the sheer expertise we have in the collaborations helps to position members to propose for, let's say, a smaller grant, like an institutional grant or a regional grant for this. At the larger level, we have put efforts into trying to leverage our diversity of expertise to help members prepare funding proposals at a higher level. One recent successful example of this is the Higgs and Simons Foundation funded program to prepare astrophysics with LSST that Rachel Street led. And you can see the link for that here. That's a good example of a successful funding proposal that leveraged sort of the size of the ecosystem that we have as science collaborations. But funding is still a challenge for us. It's very important to the science collaborations that we be as inclusive and supportive an environment as possible for anyone wanting to do Rubin science. And so Bob mentioned yesterday there's a Dei Council the science collaborations have, which has membership from Aura, SLAC, and SNWLV to harness and coordinate and promote efforts to really make the science collaborations an inclusive and supportive environment for everybody. And so you see the names of the council members on this slide, and feel free to approach any of us if you're interested to learn more about this. Turning to development, the science collaborations were heavily involved in Data Preview 0. For example, DESC created the dataset being used for DP 0.1 and 0.2. The Solar System Collaboration created the dataset being used for the DP 0.3 solar system catalogs. And there's been heavy involvement in other data preview issues, including contribution notebooks that many of you may have used to determine how Rubin analysis will actually go. I'll skip over the in-kind contributions in the interest of time, but this is another important thing that we do, is to actually direct the in-kind contributions that are coming in. So that's who we are and what we do. And now that you've heard the intro from me, I'll hand over in a minute to the science collaborations, who you'll now hear a few minutes from for each of their activities. Before I ask Colin to come and start us off with the solar system, just to remind folks, because this is a busy session, if you have questions, please feel free to put them into the Slack channel here, Day 3 WED 0900 Plenary Psycholabs, and we'll do our best to answer them. If not in real time, then as soon after as we can. Okay, so thank you all very much for your attention. I'll hand you over to our solar system co-chair, Colin Chandler.
Hello, everybody. Yes, I'm Colin Ryan Chandler. I'm a postdoc at University of Washington DRAC Institute, working as a project scientist for the LSST Interdisciplinary Network for Collaboration and Computing Link Frameworks. And I'm amazed I could say that in one breath. And I am co-chair of the Solar System Science Collaboration with Meg Schwam of Queen's University Belfast, just to tell you a few things that are going on. We have the focus points here. We're hoping to catalog 5 million main belt asteroids, nearly 300,000 Jupiter Trojans, 100,000 plus near-Earth objects, and over 40,000 Kuiper Belt objects as a highlight. So again, one of the 4 pillars, right, and we really want to discover 5 million small solar system bodies, also known as minor planets. And so just, for reference, right, we're at about 1.1, 1.2 million right now, so this is an enormous increase in the number that we know. And this is going to have something like 1 billion observations in this data set. So we are super excited, and of course this is totally unparalleled, and so we would like to actually try to be ready for that when it happens. So the Solar System Science Collaboration exists to support scientists in preparing for and using the revolutionary LSST data set and to organize the LSST Solar System Science community. And everyone who's interested is welcome to apply. And there's a website at the top just for that purpose. So a couple quick tidbits, just recent activity, what's going on. We recently have a paper out led by Meg Schwamm, tuning the LSST observing strategy for solar system science, internally known as the Cadence Kraken paper. It's definitely worth checking out on the solar system, the Astrophysical Journal supplement series. For tools, we were very excited that SORCA, which is a survey simulator post-processing tool set, was selected to be in the Link Incubator Framework program, the Link Framework Incubator, so they've been having leaps and bounds there, so we're really excited about the progress being made there. We are preparing for in-kind contributions, and we have a lot of exciting developments happening there too. We just had a sprint in Northern Arizona at the Native American Cultural Center there, pictured at left, and a bunch of stuff's coming out of there, including discussions about image processing pipelines and all kinds of good fun. Oh, and I'm a new co-chair, so forgive me as I'm spooling up. And let's say, oh, right, so what's coming, plans for the next year. So working groups are spooling up. We have elections for almost everything right now, so we're kind of excited about the amount of stirring that's happening in the groups. And just to quickly highlight what they are, there's the community software and infrastructure development. This is software, and these are tools that potentially apply beyond just the solar system, so trying to appeal to the majority of you here who are not solar system. Active objects, so comets like things that have tails, basically, which is what I'm especially interested in. NEOs and interstellar objects, we heard about the distance of 0, which we would like to avoid, and we're going to work on that. Inner solar system and outer solar system are both working groups we've got going on. And then we have a brand new technosignatures think tank. So this is looking for synergies between planetary astronomy and the technosignatures groups that are out there to see what we might have in common that we can work together on. Services deployment and development, this is like something I'm also really excited about. I'm seeing Wes in the audience there. I will just throw out there that the two systems we have for notifying us of urgent things right now both end in the word telegram. So I'm really excited that we're going to maybe work on something a little bit newer. And so we have a lot happening in that area, and Rubin's going to potentially host some forums that are related to this, so I'm very excited about those as well. We have some sprints coming. You've heard already a lot in the last couple of days, including Bob mentioned the DP 0.3, which has solar system objects in it, and we're very excited and encourage you to check that out. And to that, I'd like to also just give a big shout out and thank you to the Rubin Solar System Processing team, the Rubin Community Science team, the Rubin Science Landform, and the database teams, which we couldn't have done it without them, so we really appreciate that. And with that, I'll hand it off to the next co-chair. Thanks.
Good morning. I'm Renee Hlojek. I'm from the University of Toronto, and I'm really proud to represent the desk today. So if you don't already know about us, we are the Dark Energy Science Collaboration, and our aim, our mission, we did choose to accept it, is really to explore the physics of the dark side, so dark energy, dark matter, neutrinos, signatures of inflation, cosmology in the broadest sense. So I co-chair the desk with Tesla Geltema from the University of Santa Cruz. And this slide is very busy. There's a ton of stuff to take from it. But we're a large collaboration. We have over 1,200 members, and we have over 250 full members. So people can apply at all levels of their career to participate really fully in the desk and also have voting rights in terms of electing people like me. If you're interested in applying for desk membership, there's a link in the slides that you should be able to click on to learn all about how to get membership. And one of the things that we do is we really focus on producing the most accurate cosmology results that we can with a vibrant and inclusive community, and really focusing on trying to improve and engage with the community. We know we have a ton of big data, and so we're focusing on that. And we really want to continuously learn from one another. We focus on galaxy clusters, large-scale structure, weak lensing, strong lensing, and then time-domain supernovae sources. And we have some highlights. So we've published over 70 papers. And last year, we actually started a mentorship program where the junior members of DESK or Judo can be mentored by more senior researchers, and we hope to grow that in the coming year from 14 pairings to many more. We also have been focusing on our science plan for the year one analysis. What are we going to do in our key science goals? And we're looking at ways to bring the collaboration together. We have a lot of initiatives where we try to bring people under the same roof, under the same Zoom screen, if they're working on analyses that have similar data vectors or focus on similar things. So we have the Static Analysis Roundtable, or STAR. We also like acronyms in the desk, by the way, if you didn't notice. We also have the LSST Astronomical Time Series Classification. And so this elastic challenge is actually working with broker teams to see if we can classify and do better at classifying different kinds of transients in the LSST alert framework. And then we have also the tomographic challenge as an example of how we're looking at lensing across different estimators and different probes. In terms of the collaboration, we also work really hard to try and make sure we are modifying and correcting and adjusting our policies to make the collaboration work and function well, and so that people feel supported and included. We recently finished a demographic survey, which will then provide sort of recommendations to people like me and the management team to see how we can make that even better. Some science highlights: we have over 100 folks in the desk that are working as part of the commissioning teams, and I'm really proud and awed by all the work that they're doing. And you see some of the highlights of this plot you can see from Mike Jarvis is just showing measuring the PSF size residuals in focal plane cohorts. We also have a lot of people working in science verification and validation, using some tools and developing ways to interact with the data as soon as we can to understand if it's working well for our science. As I mentioned, we have this Static Analysis Roundtable, and we have amazing students like Irene Moskowitz who are looking at how the binning procedure changes our constraints that we get from observations like weak lensing. So how can we actually do better to chop up our data to get the best cosmology result? And then the little animation that you have here is from Justin Perel, who's showing us how we can take pixel-based analysis and actually simulate lensing of supernovae and use this as a way to test algorithms, measuring the flux and kind of characterizing these objects. So we have a lot of things that we care about. Obviously, photoz's are really important because they impact our science downstream. And you can see a lot of sessions that have already happened at this meeting where we're thinking about the impacts of photoz's on our cosmology and how we can do better using both our own analyses and also cross-correlation with other surveys. We're very invested in the survey cadence. We have a lot of folks working really hard to analyze how the cadence affects their science. Obviously, blending is a big deal because it'll impact our ability to do cosmology, and so we're trying to test our robustness. And then we obviously are understanding calibration, how we process the alerts, and then we're moving all the way from pixels to analysis with our sheer pipeline. The final thing I want to say is that we really want to work and collaborate with different science collaborations, both at the collaboration chair level, but also just one-on-one. Please reach out if you have common projects, if you have ideas and things that you think will affect galaxies and the Dark Energy Science Collaboration. We really want to be inclusive and welcoming and do a lot of great things together with Rubin Data. Thank you.
Thank you, Renee. I'm not Francois Lanous, who was called away at short notice, but I'll present very quickly the information statistics information. So this topic really cuts across all of LSST science, and ISSC has been formed as this body of experts in precisely the topics that would be needed to really take advantage of this data set that Rubin will produce. By its very nature, this collaboration is very interactive with the other collaborations. This nice figure here from the co-chairs shows you this sort of author member network of ISSC itself. But of the 130 plus members of this collaboration, their main goals are, as you see here, to provide consultation and guidance for the rest of us that didn't learn statistics at grad school, to help make good use of the data, to help develop and guide new methods to handle these data sets and new ways to get information from the data, and then to actually implement this as methodologies and coordinate those developments across the community itself to promote these sort of confluences of effort and reduce reinvention of the wheel when it's not needed. And their website there has a lot more information about what they do. Just a few highlights from the recent activities. You can see this workshop on Bayesian deep learning, that took place in the last couple of years. And then there's some examples on the archive here of some good projects that the ISSC has produced, including strong lensing, time delay estimation, tidal feature detection, good topic for this observatory, and then sort of methodologies about training these all-important photo-Z estimators. So lots of great work being done by this collaboration in collaboration with all the other collaborations and the community in general. In terms of organization, this collaboration is evolving. They've undergone a phase of recent growth. I think they say, they've got many more members than they used to. They ratified the new charter last month, which sort of lays out what members can expect and responsibilities. And they're arranging these broad interest groups and working group structures to sort of help kind of tame the madness of all of the different possible ways that these collaborations could happen. So, if you're interested in this, please get in touch with either of the ISSC chairs, Francois Lanous or Ashley Villard. They've got a SLAC channel there you can ask for information about as well. Now is a great time to get involved. They, and I think the rest of the science collaborations, are particularly interested in these inter-collaboration connections to really sort of harness the general utility of ISSC to the rest of the community. And I should probably apologize to the chairs of ISSC if you're watching that. You can ask them for more authoritative information about what it is they do. Okay, thanks for that. I will now hand over to TVS, our first co-chair, Sara Bonito.
Thank you. I am Sara Bonito. I'm a staff researcher at the Italian National Institute for Astrophysics. I'm based on the Observatory of Palermo in Italy. And I will give this overview of the Transient Variable Star Science collaboration activities in the last years. And they highlight here that, by definition, Transient Variable Star Science collaboration consists of a very diverse range of scientific topics, from galactic to extragalactic. And so we want to highlight today the main activity in the last year. We are now more than 500 members. And the community in TVS has worked hard during this year, especially with input from a survey strategy optimization effort, and more than 12 referred papers being published this year on this topic, mainly. And many members are also leaders of Kickstarter projects. And TVS is also an international science collaboration, and in fact, more than 30 in-kind projects are identified TVS Science Collaboration as the recipient for this in-kind international contribution. We didn't provide the numbers for the TVS colloquial series, but please take a look at this YouTube channel of the TVS Science Collaboration. The link provided here in this slide, because these are still ongoing, but there are a lot of scientific topics covered in this TVS colloquia. Members in TVS are also organizing workshops, schools, and conferences, and in last years, many focused on software development, data purview zero use, and in particular intense use of the Rubin Science platform by early research, early career researchers, and also undergrad students. And also survey strategy optimization workshop has been organized this year. We have asked the community in TVS to provide us with highlights, scientific highlights from each subgroup and task force in our science collaborations. And again, I will invite you to take a look at this slide deck link. And we thank all of the contributors to all of these very diverse range of scientific cases that you can find at this link. For the activities of this last year. And in fact, these activities, you can find these activities also this week during the PCW, and many sessions were led by subgroups and task forces in TVS The TVS general session was on Monday. Yesterday, the data accessibility session was organized in collaboration with the community science team. Tomorrow, the Through Novelty group will present here at PCW, and on Friday, crowded field photometry in collaboration with the Stars Milky Way local volume science collaboration as well. By definition, I was saying that the transient variable star science collaboration collect a broad range on scientific topics, and last year has been published the TVS roadmap document, and you can find here a list of the many scientific topics included on which the members of TVS is working, and also the activities of the justice, equity, diversity, and inclusion can be found in this document. And yeah, for the second part, I will call Igor.
Thank you. Hi, everyone. I'm Igor Andreoni. I'm a Neil Gehrels Fellow at University of Maryland and NASA Goddard. And I'm the other co-chair for TVS. And this year, in particular, the Kickstarter projects have been quite important for TVS. So the program involved members of TVS, as well as members of 2 other science collaborations. And thanks to about $900,000 of funding, 35 proposals were funded, that 20 of which were led by TVS members. And the person who obtained the fundings and then managed all this new ecosystem, which was quite a complex job, is Rachel Street, who's here in the room. So please join me and say thank you and acknowledge her work. Rachel also put together this nice word cloud from all the proposals that were submitted for the Kickstarters. And I think it gives a pretty good indication about what people are now interested in, are in need for. In particular, tools for data analysis, data accessibility, software, and opportunities and platforms for collaboration. So among the various opportunities that TVS has to offer, I would like to highlight in particular the task forces, which are called for from the community. They are renewed yearly and proposed on a yearly basis. And they are very precisely tasked. So unlike the subgroups that perhaps treat science topics or other more long-lived type of activities, the task forces will carry out dedicated efforts that perhaps can be also of interest of other science collaborations, which is something we definitely have to explore more. For example, the DP0 Rubin Science Platform had some learning support provided specific for TVS needs. The software task force was particularly active and had a strong connection with the international in-kind contributions. And then the commissioning, crowded field photometry, and survey strategy task forces also had quite an impact in the past year. If you're interested in knowing more about what's happening in TVS, I encourage you to attend our bi-weekly calls on Tuesdays and stay in the loop with the various communication channels, particularly SLAC, emails, community for activities of subgroup and task forces, and announcements that can be relevant to yourself or your team. And also keep looking out for fellowships that are more and more available by institutions internationally that are more and more keen to support projects related to Rubin science. And when we identify challenges, we also are trying straight away to find ways of tackling them. Definitely the lack of dedicated financial support for TVS and other science collaborations is an issue, but a lot of conversation is going on about it. And I would like to point you, again, not just to what Will said earlier, but also to the slides that were presented yesterday during the morning plenary by the reference people we have here from NSF and Department of Energy. Transitioning towards real data will be a challenge, and in the morning, in the session on last Monday, it was proposed that a new task force is started, specifically dedicated to educating people at using brokers and transitioning towards alerts. And finally, it will be a challenge to coordinate many science projects. People in TVS are free to undertake any projects they want without having to report any of that, but we are trying to understand if and how coordination can truly improve the science yield of our members. Thank you very much for your attention.
Hi everybody, so I'm Simona May. I'm from the laboratory APC IN2P3 in France, and I'm one of the 2 co-chairs of the Galaxy Science Collaboration with Sugata, who is from University of Hertfordshire. So there you see our core goal, very ambitious, perform exagalactic science over 90% of the cosmic time, and we remind you that we will have 5 billion galaxies that will be observed with LSST. So just an overview of the collaboration. We are around 300 people, and the new members are very welcome. So if you would like to join us, please contact us and look at our webpage that is there. We have monthly collaboration-wide telecons with talks and updates. And we had our first collaboration meeting in Paris in June 2023. You will find the link to the webpage. How do we work? We are organized in working groups, so active galactic nuclei, galaxy environment, galaxy morphology, low sulfur brightness science, SED fit and photometric techniques, strong lensing and survey strategy. And each one of the working groups has different convener that you will find on my presentation at the Rubin Galaxy Science Collaboration session on Monday, where you will also have presentation and highlights from the collaboration. The science roadmap has been published in these 2 papers, and I summarize here the key points. So with LSST, we will have a new window into galaxy formation evolution. We will probe the rarest cosmic environments. So the survey is very large, and we will probe environments that are not accessible to other surveys. We are in the epoch of large and deep. So we would be able to measure also the gravitational signal from this rare large halos and understand the interplay between the galaxy formation evolution and galaxy dark matter halos. Since this survey is very deep, LSST will be unique in unveiling the low sulfur brightness features around galaxies, and in this we will obtain unprecedented results. Cross your bingo card. And machine learning techniques will address galaxy study challenges such as morphological classification and the blending. To perform our science, we will need ancillary data in new observational programs that will enable us to make full use of the power of LSST. And on this, you can see a very nice presentation by Agnés Capollo on our Monday session, where a group is working a lot about ancillary data and complementary information. I will highlight here 2 areas in which the collaboration has been particularly active in this last year, and there have been a lot of effort. As we have said, we have a surveys wide and deep, so there will be extreme data volumes and an evolving data set for which the methods that we have now to study galaxy formation evolution do not hold. So we have to develop new methods for efficiently identify characterizing galaxies at the substructures, and this is especially important for morphology. We will have galaxies that have usual morphologies that we all know, and then we will have an unfamiliar and unexplored discovery space of poorly understood biases and unknown underlying population, especially on the galaxy faint end. So this is a leverage for LSST for discovering new rare or faint objects, and the large area will provide us the rare objects, and the depth will provide us with the very faint objects. So the members of the Galaxy Morphology Working Group are involved in a number of complementary projects that combine machine learning techniques, supervised and unsupervised, and non-parametric structural measures to characterize these new morphologies. They have a SLAC channel. You can contact the chair if you're interested in this work. The other area in which we will be really competitive is the low surface brightness science with Rubin. So here you see three big subjects, scientific subjects: the study of the intercluster light, stellar halos, tidal debris. So why they are important? Because they are in historical records of galaxy and cluster dynamical histories. They are sensitive probes on dark matter halos, and they probe also the cluster growth. So they are a cosmological probe of structure assembly, and then they put cosmological constraints, and then key cosmological constraints. We will observe a lot of dwarf galaxies. So here we are at the low end of the galaxy mass function. They are the most abundant kind of galaxies. They are traces of environmental influence, and they are key to numerous cosmological mysteries: the missing dwarf problem, galaxy downsizing, too big to fail. Why we don't find so many low-mass galaxies in the universe. You can see some example of work here in Mike Jones' presentation on the Rubin Galaxy section on Monday. You also have a large area, so we will probe the rare and the extreme. Here you have some example: giant LBS, ultra faint, ultra LBS, that's rich LBS, for which you have the presentation at the Rubin Galaxy section also on Monday. Just to highlight one result that was very much discussed in the collaboration, both in our collaboration meeting and on Monday. The first question we want to ask is, do observers and simulators measure the same quantity of intracluster light? And Sarah gave a great presentation. Here is the result. She used the simulations from state-of-the-art simulation sets that you find on the slide, and she compared it with what we find applying usual methods that are used by observers to recover the intracluster light. And what she found is that the brightest cluster of galaxies plus ICL light fractions are offset from simulation by 0.05 dex. This doesn't seem very large with respect to the scatter, but it's a systematic scatter that we always find. And if you want to do precise measurements of the ICL, we have to develop new methods to make more precise measurement if you want to compare them with simulations. For the future, the current collaboration-wide discussion are mainly focused on our publication policy. We don't have a publication policy. So far, we have used the publication policy from Rubin because we are using Rubin products. However, now we are developing products that are more specific Galaxies products. So we put together a committee, and a draft will be circulated in the next few months for collaboration-wide input. We're also focusing on the input to commissioning and kind contribution to the sitcom, the definition of the science validation metrics that are more relevant for galaxy studies, and we're helping to refine the SV targets. A large effort should be put in the next years to find out to better engage with early science, and this will be the focus of our next meetings. So that's it. Thank you very much.
Thanks very much, Simona. You have me again for SNWLV. So Stars Milky Way Local Volume covers an enormous range of topics, all the way from nearby stars to local volume dwarfs. You can see the sort of ambitious range of avenues the group is attempting to pursue here on the slide here. We now have about 190 members, of which about 110 are also in other science collaborations, all of which are working on these ideas. Some recent activities to highlight for this group. The star clusters subgroup has become very active in the last year or so, particularly led by Kristen Daig and Chris Usher. This shows you just two products from the group this last year, including a roadmap for extragalactic star cluster science with Roman, combined with Rubin, and then a new science roadmap. Just it asks questions: what are the science questions that this science area needs to address, and how will Rubin do this? Also newly active in SNWLV is the Near-Field Cosmology subgroup that's been resuscitated by Max Dalora of INAF in Naples. It's been active since about 2022 with about just under 40 members and is producing, again, roadmaps and starting to collaborate with other groups as well. We're particularly happy to see this collaboration with the DESC Dark Matter subgroup, with which there's a lot of, I think, connecting tissue in the science. The galactic part of SNWLV, the galactic structure and ISM subgroup, is also resuscitated somewhat in the last year or so. Peregrine McGehee has been leading this, and their current focus is on actually sort of updating the scientific roadmap from the version in the 2009 science book for LSST, given that there's been quite a lot of development in the last in the years since the science book came out. Turning from scientific areas to technical areas, the joint SNWLV TVS Crowded Field Task Force has become active again in the last few years. Specific activities include development of a new code for period searching based on Rubin LSST data from the Kickstarter program that Igor announced earlier on this meeting, examining the all-important questions of how deep can you go in crowded stellar fields, what techniques work best. Is it the case that off-the-shelf techniques do what the particular science goals need for that area? And you can see some of the future projects this group will be involved with up on the slide here. For those interested, by the way, there will be a crowded stellar field session this coming Friday at 9 o'clock that was proposed by this subgroup to follow some of these questions in a little bit more detail. Before I hand over to Tansu for the strong lensing collaboration, I want to just highlight one more thing, which is, of course, the all-important survey strategy that SNWLV has been involved with. For a lot of our science in this group, we sort of have the parts that are a bit difficult, I think, for surveys to reach, including the Magellanic Clouds and the inner Milky Way, but not just the inner Milky Way. The sort of extended plane is also of interest. And I think this has been announced already, but this meeting, but there's a new joint task force led by Rachel Street and Jay Strader, both of whom were at this meeting, to work to help sort of refine what the observing strategy really should be for Rubin towards the plane and what metrics can be useful for sort of assessing this. And that's coming in the next few months. So that's a quick set of highlights of what this collaboration has been up to recently. Thanks for your attention. And I'll hand it over to Tansu Dalen to tell us a bit about the Strong Lensing Science Collaboration.
Thanks, Will. Hi, everyone. So I'm Tansu Dalen. I'm a new assistant professor at Washington University in St. Louis. And also, until very recently, I was a Catalyst Fellow, an LSSTC Catalyst Fellow. And I'm very pleased to be representing the Strong Lensing Science Collaboration today. So our co-chairs are Graham Smith and Timo Anguita. And we'll have a phase transition in September where Simon Beer will be a new co-chair replacing Timo. So we have about 120 members, and we are all excited about strong lenses. So as you may already know, LSST will be discovering many tens of thousands and likely 100,000 strong lenses. These will be in the form of galaxy type lenses, quasars, and clusters of galaxies. And we will be able to learn a lot about the structure, the contents of these objects, their dark matter substructure, their kinematics, their concentrations, etc. We also have the so-called time delay cosmography, which allows us to probe cosmology using these lens transients. We have quasar microlensing, which allows us to probe the accretion disk structure of these AGN. And we can also use strong lenses as gravitational telescopes. They allow us to focus on and magnify very high redshift objects. And finally, we also can learn about the transients themselves using strong lensing, not just use as a cosmological probe. So we have a lot of active projects which I don't have time to go into individually. We essentially develop a strong lensing pipeline jointly with the strong lensing topical team as part of DESK. And this pipeline includes machine learning and citizen science and modeling. We also have watch lists that will allow rapid discovery of these lens transients. We have a few in-kind contributions. We also take part in the commissioning. Where we test the difference image analysis pipeline and the blending and the image quality using archival Cosmos field data. And finally, we also take part in the foremost strong lensing spectroscopic legacy survey for SLS, which is going to measure the redshifts and velocity dispersions of many thousands of the strong lenses that will be discovered using Euclid and LSST. So doing science with strong lensing requires a lot of critical requirements. Essentially, we require that there's good seeing in the bluest possible filters, so we can actually study these strong lenses which require good angular resolution. We require an early reference survey in order for transients to be rapidly discovered. We are thinking of a target of opportunity to include observations deeper than wide, fast, deep survey. But to note, we do indeed require a large survey. We prefer survey area over cadence because strong lenses have a small cross-section. It's a rare event. They're exciting, but they're rare. So this picture essentially shows an overall schematic of the pipeline. As a note, you can't do strong lensing science with just the LSST data. You need high-resolution imaging. You need spectroscopy, as I mentioned. So these essentially all leak into what we do with the LSST data to discover and characterize these strong lenses. There is a lot of simulation work that goes into it. In fact, we just had a simulation workshop, a remote workshop in April. And we also need to take into account the environments, the shear that comes from the large-scale structure of the universe. I may not have time to go into detail on this slide. This is just to say that we have a complicated structure to discover and model these lenses across all scales. And we need your contribution. So if you're excited about strong lensing, please do consider joining the collaboration. It's a relatively small collaboration. And as you can imagine, what brings us together is this share of know-how on strong lensing. And the more we efficiently share this know-how, the better the science cases that I described in the very early on will be done. So even though we have a lot of science cases, we do share a methodology, and we welcome you to work with us on this. There are other ways to get involved, by the way. We have an ethics panel, with which I'm a member, and we also consider cases where there could potentially be violations of the code of conduct, so we have a panel for that. We also manage in-kind contributions. We have, as I mentioned, we have an infrastructure to detect and model strong lenses. We have opportunities to work as liaisons with the other science collaborations because, as I mentioned, strong lensing is a methodological science collaboration. And beyond that, I would like to highlight one thing, which is that we will be having an LSST-wide strong lensing focused face-to-face meeting in March 2024 in Oxford. So if you're interested in strong lensing, please, and if you're nearby and have the means to join, please do consider attending that in-person meeting. We do also have monthly telecons, I believe 3 p.m. UTC on the third Wednesday of every month. So please also, if you're interested, come join us and attend these meetings. With that, I thank you for your attention.
Hello, everyone. Franz Bauer from Universidad Católica in Chile. I'm the highest ranking member of the AGN Collaboration who's here, representing both Neil Brandt and Gordon Richards, who are the chairs. I was largely given these slides. I think they're a little bit sparse on some of the information. Basically, the AGN that we expect from LSST, we expect maybe to detect up to 75 million directly with the LSST data, and maybe detect 300 million where we don't actually know that they're there, but they're there, compared to the 5 billion galaxies that Simona mentioned before. And so we want to do, time variability studies, demographics, you name it, photometric redshifts, finding binary black hole systems, interesting types of supermassive black hole transients, et cetera. So we have a bunch of, we have, I think, 4 working groups, one on classification, one on photometric redshifts, specifically for AGN, which tend to be outliers in the galaxy photometric redshifts, another one on follow-up, and another one on, I'm blanking on it, variability, AGN physics, that type of thing. And so they typically have monthly meetings. We also have a global monthly meeting as well, online. The current membership, we're about 180 members strong. We grew by about 20% over the last year, so really quite a big increase. Among those, we have a very low bar for sort of entry membership, associate membership, and so most people are sitting at that level, and then we have 13 members who are now full members. Neil put together this list of sort of breakdown of by country. So obviously the U.S. is the largest contributor, but with about 50%, and then we have a very international sort of flavor from there. In terms of the specific highlights of the last year, we recently sort of concluded an AGN Science Collaboration meeting. We have one about every year, typically in July. This one was at NRAO, hosted by NRAO and NASC in Charlottesville, and we had about 35 people in person, 10 people online, discussing the various issues that have cropped up, presentations and sort of exciting things that we might be able to expect. Many of the members also attended a conference the month before, Restless Nature of AGNs in Napoli, and there again we were hashing out some of the interesting science and problems that we have to face. There was a recent AGN data challenge a couple of years ago that was put together by Gordon Richards and his student Wei Jing. And there's now a paper from the results of that, which is coming out, Savick et al. 2023, that was accepted. There were prizes that were sort of funded from the LSST Corporation, now the Discovery Alliance, but the actual putting together of that challenge was more or less unfunded. And so we also have been working towards implementing a project posting system that is more or less an open source, free version. And so this is hopefully going to encourage more internal collaboration. If you're interested in that from the other science collaborations that aren't desk, you can talk to Chris Carroll. He's in the audience somewhere. And he was one of the people who helped spin this up. In terms of challenges and opportunities, we were told to sort of mention this. One of the problems that we continually face is that there's insufficient funding at a broad level to effectively engage with all of the exciting things that are happening in Rubin. So we have problems engaging with the software engineers in Link. We have problems keeping up with and keeping track of the in-kind contributions. We have problems interacting with the Catalyst Fellows and actually putting in all the things we would like to sort of see in the cadence optimization. And at least the people in the US estimate that they need something like 50,000 in order to sort of properly fund these things that they don't have. That isn't for lack of trying. They have been putting in proposals and putting in proposals. And in fact, Gordon is stepping down as one of the chairs, primarily because he needs to fund his grad students and he needs to put more time into that, although he also wants to give opportunities to younger folks. So there's an opportunity there for people to join the AGN collaboration and contribute. Certainly there's opportunities for leadership and so forth. So thank you.
Thanks very much, Franz. And just to get a break, let's thank all of our speakers again for their great presentations. I'd like to particularly thank Franz and Tanzi for stepping up to present collaborations in which they're not chairs. Okay, so before we hand over to the lightning stories in about just under 10 minutes, I want to finish up just to identify a few of the things that the science collaborations chairs have identified that we're concerned about, that we've actually identified these before this workshop. Many of these issues, the discussion is happening at this workshop, so that's been terrific to see. But just for the record, here are some things that we are a little bit concerned about. We'd like to try to work to solve these issues. You've heard about the funding challenge a few times in this plenary. We're very grateful for the interactions both with the Discovery Alliance and other funding bodies that have been, I think, very helpful in funding the kinds of investigations we'd like to do at very different levels. There's some examples here of early science program uses that collaborations have put to this. But as you've heard, it still remains the case that obtaining support for graduate student funding, for example, for science exploitation is still a challenge and key priority. The majority of science collaboration in science is still unfunded. So in that context, it's really great to hear some of the discussion, particularly yesterday, from the agencies about possible avenues for this. And we're looking forward to continuing the conversation about this. But this is something that we're working on. The funding landscape at the slightly lower level is also a little bit unclear, in particular how these activities like sprints will be funded, particularly travel support for early career and underrepresented groups in STEM is also something we're interested in moving the needle on. So we look forward to continuing those conversations as well and welcome ideas for how these are to be funded. So very grateful for funding so far, but there's always a need for more. A few avenues of issues I think we should be in a position to solve. You can expect there'll be big proposals from the community for follow-up science, for example, on the order of 2024 May. And so we will need updates on the commissioning timeline on that kind of time frame. We've heard some methods at this meeting already about how to do that, which is great. But this is a concern that we have. One example is how will in-kind contributions of observing time work. Those in-kind contributions that have been given to allocate observing time in return for data rights. It'd be good for us to know how that's going to work. How do we propose for that time? And we realize it may be sort of case-by-case thing, but it would be good to know this. Similar questions for observing strategy, just in terms of the sheer requirement to set aside effort to work on these questions. The more concrete plans we can get for when decisions will be made, even if not what the decisions are, the better. So we look forward to working with the SCOC to try to nail down these timelines. Commissioning is another issue we're very interested in. And we'd like to know sort of what the best way is for us to work with the commissioning groups to help to make sure this is a success for the project and also for the science. A couple of example questions are up here on the board here. What communication can we expect? That'd be good to know. And should we wish to go back to the commissioning products ourselves and let's say do our own analysis of ultra-bright objects that bleed, for example? Will the commissioning products be separated in that level so we can just pick out what we would want to do for investigations that might interest us if we have another use for that data? would be good to know. The last two concerns, just to bring them up. These meetings are wonderful, very useful. I don't think it's any secret, though, that for those at the early career end of the spectrum, it can be quite difficult to attend multiple meetings per year. So we've put some ideas up here on the slides to read afterwards if people are interested about ways in which this might be more accessible from our point of view as unfunded science collaborations in general to actually attend these meetings, again with an emphasis on allowing early career researchers to do this. As I think you've heard through this talk already, all the science collaborations are in some sense person-powered limited. That's both in terms of the science itself, members to help with the various activities we do, but also in terms of actually running the science collaborations. There's a lot of effort that goes into actually doing issues like you heard from Tansu for codes of conduct, or from wrangling the membership, entering into the database new members, working groups within science collaborations. That takes effort. I would point out that for early career researchers, this is a great opportunity to get experience in leadership and sort of multinational collaboration without having to sink all the effort that goes into being a co-chair. So ambitious early career researchers, this kind of activity, being a working group chair, is a great way to sort of expand your own horizons and really contribute to the direction of the science collaborations. So I'll finish up. I hope that for some of you in the audience, this presentation and this plenary has filled you with enthusiasm for the science collaborations and the science that Rubin will do. To get involved, you can either email me or any of the science collaboration co-chairs, or you can navigate to the Science Collaborations page at the Discovery Alliance website. You can also get to this through the rubinobservatory.org website. It's a few clicks through the For Scientists pad, but we welcome all input, and all effort is welcome. So thank you all very much for listening. Okay, so with that, I'll hand over to the lightning stories from Stephanie. Thank you.
Hi, everybody. We're switching gears a little bit for the last part of this plenary for our 2023 lightning stories. So for some context behind these, as we all know, Rubin Observatory would not be possible with all of you and all of the people making this incredible observatory a reality. And so the lightning stories are a series of very short 4 to 5 minute talks, 3 slides, from a few of our community here to introduce themselves so we can highlight some of the incredible people who are making this observatory real. So with that, I will invite Julio Constanzo to come up first, and we'll cycle through our 4 lightning stories for this year.
All right. My name is Julio Constanzo. I'm the IT network engineer, part of the IT South team. And this is how my journey started. So fun fact number 1, that I was working in the ALMA project when I was a contractor during the period of 2015 to 16. And that was the first time when I heard about the LSST project. Actually, the person that told me about it is here right now, so he knows who is it. So thank you very much. Fun fact number 2, during the early 2018, I quit my job. I was working as a network engineer for a big insurance company. I was not happy. It didn't mean something to me. It was just money to all other people. So I really want to go into music again. I studied music as a first. And then I went to engineering. So the kid in me still wanted to be a rock star. So I quit my job. And just an hour later, the LSST HR called me and said to me, hey, you're ready. So then my life changed. I came here as a user help desk support for the project. I was a network engineer, but I didn't mind. I really wanted to be here, so I took the chance, and during the COVID-19 pandemic, I was the only network engineer on site to support the construction. So even I was a user support engineer, I went to the network side of the project and trying to still go with the construction. So then the summer shut down and the power on challenge came. So I had the chance to help with that. It was a big challenge. Then a few years later, we have the ACI review, and for those who know the ACI, well, it was a really pain and suffering time for me and the project. So then when the network engineering came, we had the chance to strip out the ACI, which I'm pretty happy about it. Yeah. So now we have a new infrastructure. We're still working on it, and we're going to put all our efforts on it. So, well, I was part of the highlights, and you can see we have also the Summit Maintenance Team Award, so that was real cool. And also, it's a long way to the top if you want to rock and roll. I'm still a musician. I still love to play guitar. And fun fact number 2 is that I used to play in a thrash band. So I tour a lot. I play a lot in a lot of festivals and everything. So that's me with my hair not tied. And the other part of this slide is just for my kid and my parents. So I'm gonna read that line, which says, "Someday you're gonna to look back on all the progress you have made and be glad you didn't quit." I'm glad that I took the chance. I'm glad to be here, and I hope you are happy with the work that we're doing, because we are putting a lot of effort. So thanks to my dad and my kid. Thank you very much.
Hi everyone, I'm Agnés Ferté. I'm a Rubin operations scientist at SLAC, and I started working for Rubin actually a year and a day ago. And since I got my PhD 9 years ago, I spent a lot of my days and a lot of my nights being very anxious trying to prove Einstein wrong. So indeed, an alternative to dark energy to explain the cosmic acceleration is to say that general relativity, our theory of gravity, is incomplete on cosmological scales. And more generally, we're also, with galaxy surveys like Dark Energy Survey and LSST, we're able to test GR with very high precision because we test GR very precisely on astrophysical scales, and now we can do it on cosmic scales. So I have been using weak lensing and clustering data from the Dark Energy Survey, and most recently from the 3 years of observation. We haven't detected any deviation from GR yet, but with LSST, I showed that we could expect a gain of 1 order of magnitude on the precision of test of gravity. This forecast is pretty optimistic, but I think it's a great goal to have. And to get there, I think more than ever, it's very important to have a very deep understanding of the data. So I'm very happy I joined the incredible calibration team that's led by Chris Waters. Yes, amazing job. Very hardworking people, so we're contributing to the instrument signature removal pipeline, which will allow you to get data that are clean from detector effects. So that's half of my time. The other half of my time, I'm a member of the in-kind program coordination team, the IPC team, led by the exceptional Aprajita Verma. And yes, again, so I coordinate a few international in-kind contributions, especially software, and we would love to have you at some of our sessions today. So that's 100% of my time, but I have 50% more of my time. So I really want to get to the end of the full dark energy survey. So we are working really hard on to get the cosmology from the weak lensing and clustering data. and I'm working on how to model it and to do the cosmological analysis. I've also led some application of machine learning, and of course this will also be very important for the Rubin Observatory to analyze the data, so please come to our session on Friday that's co-chaired with Yunyan Zheng. I also think that being a scientist is incredible chance, you know, to be paid to work on galaxies, like what? And so I really want that to be a possibility for everyone who wants to join science. So I work in the desk EDI committee and to make the workplace a safer and healthier environment. And generally, I'm exploring outreach with podcasts and videos. And yesterday, Aaron Messner and myself gave a talk at a pub here, which was really fun. And I'm also starting to do outreach on climate change because, okay, dark energy is pretty important, but maybe climate change is more urgent. It's been urgent for 30 years already. And it's really nice to see that Rubin has planned to be carbon neutral. So overall, I think we're like on the verge of a big leap in cosmology. I can't wait to use the LSST data. But as Julio says, we have to rock and roll. But my French side tell me that we also have to take break and take care of ourselves. Thank you.
Hello, everybody. I am Clare Higgs, and I am the astronomer on the Education and Public Outreach team. So I wanted to start off today talking about my road to Rubin, because I took a slightly long and winding path. So my younger self really loved animals. That's my horse. Oh, that's my horse up there on the side. And I wanted to be a vet. I went to university and doing my undergrad thinking I was going to study biology or ecology or animals or something like that. And it took one really amazing physics teacher and one slightly lackluster biology experience to veer me in a different direction. And I started to take more physics courses, including some astronomy courses. I had some great undergrad experiences. That's me in the middle in Snow Lab in Northern Ontario. During a summer job, and that grew with many more astronomy courses, and I was really fortunate to have some amazing fun experiences, like visiting the Canada-France-Y telescope, that's the little orange picture, and up in Mauna Kea. And so this led to a master's at the University of Victoria, which spiraled, as these things do, into a PhD in which I studied resolved stellar populations in nearby isolated dwarf galaxies. And so that's a picture of Leo A, which is one of my absolute favorite dwarf galaxies, and I think it's just beautiful. And so as I started to reach the end of my PhD in 2021, and I didn't really know what I wanted to do next, but I knew I wanted to do a bit of research. I really wanted to do something outreach and communications, and I wanted to be part of something cool and cutting edge and novel, and I thought this was an impossible laundry list to find the right job, but I was really lucky to find this job at Rubin. And so I started just over a year ago and attended last year's PCW as a moderately overwhelming Rubin crash course. So this year is much more manageable, and it's great to be back here. So my role on the Education and Public Outreach team is providing science data, astro support to our amazingly talented public outreach team who come from a diverse number of backgrounds, so I provide everything from jargon and acronym support and data and so on. One of my principal day-to-day focuses is working on the citizen science pipeline, hopefully making it easy for all of you to make citizen science projects for the public. So if you're interested in citizen science, I'd love to talk to you. Another example of my day-to-day is providing interim data for our suite of education investigations. So these investigations will allow Rubin data to be in classrooms, but in lieu of data, providing appropriate substitutes for the time being. So that keeps me very busy. And so To close, I wanted to share this photo that I took from the Magellan observatories in Chile in 2017. I was lucky enough to go observing there during my PhD, and at the time I was there, I had no idea that one day I'd be so invested on something that was happening on a ridge about 85 miles or 140 kilometers from my metric friends away on a different Chilean ridge. And so this observing trip happened in the doldrums of my degree. And was really a turning point for me that both re-inspired and reinvigorated me and reminded me why I was doing all of this, but also opened a lot of new doors. So while I was there, on the first night that I was there, and I was shadowing the astronomer that was observing that night, just so happened to be the neutron star merger night. And so I was there and saw the blob on the screen and being part of that moment. And that really changed my path as well, because through my university, I was part of a couple press releases and little media interviews, and it really cemented for me how fun sharing cool science with the public is and how amazing an opportunity that is. So I feel really privileged to be part of Rubin EPO and the Rubin community as we get ready to show some really cool science to the world. So thank you very much.
All right, so everyone, I'm Ryan Lau. I'm a community scientist on the community science team. I joined Rubin, I guess, the same time as Clare, around July 2022. So again, like, this is my second PCW, but the first one that I went to was like, yeah, super overwhelming. So here's just a short bio about myself. I was born and raised in Honolulu, Hawaii. Now I'm an assistant astronomer at NORLAB in Tucson, so kind of right down the street. And as I mentioned, I've been a member of the community science team since about last year. Also, part of my time is with the Community Science and Data Center, so CSDC. And in the other 50% is kind of my free research time. I got my PhD from Cornell University, studying the extreme environment of the Galactic Center using the Stratospheric Observatory for Infrared Astronomy, SOFIA, so that's the plane on the top right. It was a 747 SP with a 2.5-meter telescope in the rear left fuselage of the plane. Unfortunately, it's no longer operating, but it's actually here in Tucson at the Pima Air and Space Museum. I haven't seen it yet, but at some point I'll probably go over there. So there's a picture of myself in grad school. I think this is like my first flight on the plane, and that was like right after I told my PhD advisor, Terry Herder, that, oh yeah, I want to join your project. And then it was like a couple weeks later, I'm flying on the plane. So again, like this fire hose of information coming at me. And I think the confusion that I felt when I was on the plane is visible there by my expression. So for research, what I've been doing lately is I'm part of this early release science team with JWST. My interests are in dust, massive stars, so that's kind of what we observed. So there you see this these nested dust shells from a Wolf-Rayet binary. And that was a pretty crazy project to be involved in because our data were public right away. So there are all these kind of interesting theories as to what was going on. In fact, we didn't anticipate that the public would download this image and start posting about it before other like competitors or anything. So there are some interesting theories going around about alien megastructures and things like that. So we were really motivated to get a paper out to make sure that that's not the headline about this result. So at NORLAB and with Rubin, I'm looking forward to synergies with JWST, Rubin, and other NORLAB facilities like Gemini, KitPeak, and CTIO to find other interesting types of infrared luminous transients, kind of like these here in the JWST image. So what exactly do I do as a community scientist? So what I kind of see my main role as is to support astronomers in the Rubin community to use Rubin data to do the best science that they can. And one of the key things about this is kind of familiarizing users with the Rubin Science Platform, or the RSP. It's going to be a totally different way of doing data analysis when Rubin data start coming in, because it's more of this next to the data analysis instead of downloading, I don't know, petabytes of stuff on your laptop. So you need this kind of RSP to do this science. So currently, we've been working with Data Preview 0.2, and then now there's also Data Preview 0.3 that has come out, including solar system objects that include LSST-like, simulated LSST-like data. So based on my own research interests, this is focused on my interests are focused on time domain science cases like transients and variables. So here's the light curve that you can actually make right now using the RSP on simulated data. And there's a little animation of this 1A supernova that's been simulated in the DC2 data set. Yeah, so in my free time, I like to play music and skateboard. So here's me playing a show in Pasadena back when we were in a band called the Post-Documentarians. It was a pretty fun name because we were 2 postdocs and then a documentary filmmaker, so we're like, we'll just put it together, Post-Documentarians, so it was pretty cool. Unfortunately, we don't play anymore, but yeah, I want to get started again playing music. Maybe I'll ask Julio, we can start a thrash rock band or something like that. That'd be fun. Yeah, the other things I like to do, I like to skateboard. So this is me doing a 360 flip at a skate park in Catalina High School like a couple months ago. I have skate park in quotes because it's really just like a flat surface, so there's nothing really much there, but it's a nice, relaxing environment because you can see the kind of the Catalina mountains in the background. So that's it. So thanks for your attention. Please feel free to come to talk to me about astronomy, music, skateboarding, how to make a light curve with the RSP. Yeah, thanks for your attention.
Are we doing this next part? Can I invite Diane Haskell up?
Hi, my name is Diane Haskell. I am a mechanical and systems engineer for the LSST camera and commissioning, and I also designed a mini Lego model of the Rubin Observatory. So to answer a few frequently asked questions about this model, I designed this using a web-based software. It's basically a CAD-like environment that has a library of all the Lego parts, and you can drag and drop them and move them around and virtually assemble a model. So that means that this model is built with entirely standard Lego parts and colors, including a lovely teal color. So that means there are no custom parts and no 3D printed parts. There are about 770 bricks in this. It is entirely solid on the inside, and it weighs almost 2 pounds. I have completely lost track of the many, many hours that it took to design this, but it took about 5 hours for me to assemble. While I do not have assembly instructions, I do have a bill of materials for this. That's a list of all the parts that are required to build it. I plan to update that bill of materials with a link to the 3D model, a bunch of information and tips and tricks about where to buy parts, how to assemble it. And I will be releasing that publicly in the next month or two so that anybody who wants to build one of these will be able to. I will be carrying this around with me all today and tomorrow, so if you want to take a closer look or take any photos, you can come find me, and it will also be at the EPO open house tomorrow afternoon. Thank you.
That is a great teaser for a project that the Education and Public Outreach team has also been spearheading. That is going to be much more of an accessible model for the everyday person to buy. But what we have been working on in EPO is working with a astronomer and Lego extraordinaire specialist who is designing a large Lego model of Rubin Observatory. It's going to be about 60 centimeters in length. It includes all of the interactable parts you would hope that a Rubin Observatory Lego model would include, including controls to be able to move the TMA in altitude and azimuth. You can rotate the dome. The dome rotates with the TMA when you rotate it. You can remove the dome and explore the inside. The dome shutters and windscreen also move. You can open and close the vents on the dome. The P-flow elevator shaft is also functional. You can remove the service building roof to look at the inside. You can totally remove the control room floor and move little Lego figures around the control room. So I am not able to share screenshots quite yet. The design isn't final, but come find me. I'm happy to show them to you. And this will be a model that I hope our various centers will be able to purchase. It'll be a similar situation as Diane's. It'll have a part list. We're trying to get a build instructions manual too, because this is going to be a 10,000 piece Lego model. But I'm very excited about it, and it is nearing final design completion. So please come find me if you want to see some screenshots of the design of that. And with that, I think I'm done. I don't know if there's more for this plenary.
Okay, just two reminders before we go. One is that the unconference is later this afternoon, so your times to vote for the unconference topics are now and right at the beginning of lunch. By the end of lunch, I will have rooms assigned, and it'll be posted in SLAC, and it'll be posted on the board, and also in the website. The second reminder is that there's a new set of posters today, and now is the poster session for the new set. Now and after tomorrow's plenary. So go see the new posters. And Bob.
Thanks, everyone. That was a great session. I just came up to remind us real briefly of how fortunate we all are to be here doing this kind of thing. Astronomy and physics are, wonderful opportunities for many of us. And they take us to many great places. And over the more recent years, a lot of those places we found have become endangered by things happening with our climate. This is another northern summer. Last year we had a serious fire that went over the top of Kitt Peak. And you may have seen this morning that there are serious fires on the Big Island in Maui in Hawaii. I don't think any telescopes are immediately in danger. However, many of our friends, colleagues, and communities are dealing with a very serious situation. And I just wanted to mention that and give you the opportunity to think about it and send good thoughts or prayers if that's your thing. And maybe in the near future we'll have opportunity to support those folks in other ways. So just something to think about as we go through the day. Thanks.